Hello, it is Dr. Lou. In case you have not watched the prior videos, I am the lead faculty member who has created the online laboratory classes using Kids from Science Interactive. In today's video, I'm going to explain how we are going to observe a buffer. We are looking at buffers. Before I explain the buffer system we're going to work with, I want to refresh your memory as to what is a buffer. So a buffer can be a weak acid and its conjugate what? Base, or a buffer can be a weak base and its conjugate acid. The two important aspects of a buffer is we must have a weak acid or a weak base, and we must have its conjugate. So when we have a weak acid, the change in concentration of a weak acid is not going to change the pH very much. Same thing is true for a base. So the acidic component of a buffer reacts with base. So if we add a base to a buffer or something basic to a buffer, we can neutralize the base with the acidic component, the basic component reacts with the acid. Now, of course, if we add a lot of base or a lot of acid to a buffer, we may see a change in pH because we have overloaded the buffer and have exceeded the buffering capacity. Additionally, sometimes there might be a small change in pH upon the first drop or two addition of a acid or a base to a buffer, but then the pH stays relatively constant upon addition of more acid and base. So I want to look at the specific buffering system for this experiment. So we're going to look at carbonic acid bicarbonate buffer. So the buffer is going to be made up of H2CO3 and NaHCO3. This is carbonic acid. Here we have sodium bicarbonate. I'm crossing out the sodium. Why? Sodium is a spectator. It is not part of the actual buffer. But remember, we cannot have ions existing in nature by themselves. They must be part of a salt. So what is the key to the buffer really is we're looking at this HCO3 minus. So if we add a base to this particular buffer system, the H2CO3 plus, let's say, some hydroxide what is that going to give us? That's going to give us HCO3 minus plus H2O. If we were to add an acid to a buffer, to this buffer, we could take HCO3 minus plus H3O plus, which will give us H2CO3 plus H2O. So notice what essentially happened in a buffer is the base added will react with the acid, producing water. The acid added will react with the basic part of the buffer. And what are we going to produce? Again, water. This experiment is framed in terms of a living system. Why? What is necessary for us to live? We need to undergo what? Respiration, which involves breathing in air, and we take in oxygen. And then what is released from the body during respiration? Oh, there will be components of air that we don't need, but also carbon dioxide. So I want to show you this chemical reaction. So when carbon dioxide is dissolved in water, it is in the form of carbonic acid. So I'm going to write down H2CO3. This is going to be aqueous. And if it comes out of solution, we will have H2O liquid plus CO2, which is a gas. And I will draw a double arrow because we have this equilibrium here. CO2 is a gas produced when? When we exhale during respiration. So we are going to make the buffer by dissolving sodium bicarbonate in water, and then we're going to generate the carbonic acid. So by blowing in the water, we make H2CO3. So if we blow into a cup of water containing baking soda, we will automatically produce the same buffer that is found in our blood system. So not only is carbon dioxide a byproduct of respiration, but it also forms carbonic acid in our bloodstream that will help what? Create this natural buffer that will keep the pH of our blood relatively constant. So when we make this buffer solution, then we're going to add some acid, HCl, to the buffer. We're going to add HCl to deionized water for reference. Then we are going to make a plot. So let me show you the plot we are going to make. So let's draw the axes. This is going to be my, whoops, it moved a little bit, I apologize. Here is going to be my y-axis. There we go. Let's draw my x-axis. down here, and let's try. There we go. So we're going to label, this side is going to be pH. On this side, we're going to have drops of HCl. And so we're going to call this, green is going to be my buffer, and blue is going to be the just plain water for reference. So we're going to plot some data. So we're going to start with a pH, and the pH of the buffer is probably going to be, somewhere. We're going to start with a pH somewhere up here of water. pH of water is going to be where? 7. So let me write here for reference a 7. That's where we're going to have neutral. Okay, so we're starting with some water, and we add HCl to the water, and as we add more HCl, what happens? It looks like the pH happens to what? Drop. So now we're going to have our buffered solution. So what happened with our buffered solution? The pH stayed what? Relatively constant. And then what do I see at the very end? If we added enough acid to the buffered solution, then we would need, we would have a change in pH. Why? Because we've had gone past the buffering capacity. What's missing from this graph is the title. So we want to say pH of buffer solution. And what do you want to remember when making a graph? You must use graph paper.